left with one digit, 24 versus 23. If you've only one digit, you'd say it's nearer 20 than it is 30. So you'd say it's 20 or 2 to the power 2 by 10 to the 1. So that's the way you do it. So if we look at that then in terms of the digits, that's how we represent that. So it might say calculate the expression or the value of the expression below, 165.7 plus that divided by this. So we add the two numbers on the top and we get 210.51. They're of the same sort of order. We have two decimal places here, so we have two decimal places here. And 132 by 10 to the 5. Well, 132 by 10 to the 5 means that we take this number and move it 5 places to the right. 1, 2, 3, 4, 5. So 132,000 there. We multiply the two by that divided by that, and we get 0.001594772. But that's a bit of a mess. We'd like to simplify that, and we say how much do we have to move to have the dot in between the first and the second? So 1, 2, 3 places. That would give us there 0.00159. 3 places would be that by 10 to the minus 3. Because if we take 1 and we multiply by 1,000, we also have to divide by 1,000. This gives us this number on the top, the 1.59, and on the bottom, 10 to the 3 on the bottom or 10 to the minus 3 on the top. So that's how we represent that, and that's our significant digits. We now look at relative and percentage errors. Let's consider this example where you're coming in and you know that the conversion rate on the day is 87 pence sterling for a euro. And you want to convert 40 sterling to euro. What would you get to the nearest euro? Well, we write the numbers down and we say, well, 1 euro is giving us 0.87 sterling. If we go in with 40 sterling, keeping the sterling line here, what would we get in terms of x? And that's a standard ratio question. So we do the simplification and we say, for 1 you get 0.87, what would 40 give you? Looking horizontally. Or we can do the crisscross. So 1 times 40 is 0.8 times 7 times x, and you work out your x value, and you find that your x value is €45 and 9.977. But the question that was asked was, if the conversion was truncated to the nearest euro. So in this case, the truncation is not to 98 pence or 98 cent, but actually to €45, because the bank or the exchange facility is not carrying coins. So you're now only getting €45. When truncated to the nearest euro, you lose everything above the point. The question asked now is, what's the relative error? Well, you thought you were going to get a full, on the conversion rate, 45.977. And all you got was 45. So in other words, 100% of what you wanted is that, but you didn't get 100%. So we can do that either as a percentage or as a ratio. The relative error is the ratio of the error to the correct answer. And really what we're saying is, this is the correct answer. The full amount, 1 or 100%, would have been 45.977. And all I got was this amount. All I got, that should be 40. That's the error. The error, how big is the error? The amount I got was 45. That's correct. The error was 0.977. So how much of that, 0.977, what fraction of that is that? Now, it's a small amount. So what fraction is 0.977 of the 1? If 45.97 is 1, how much is that? A small amount, really. Quite small. Let's multiply the calculations out. And we say, if 49.977 is the total, how much would that reflect? Do the crisscross, multiply across. 0.977 by 1 is that by x. x turns out to be 0.02124975. So quite a long calculation. Or that's the fraction. 0.02 of it was error. Here's the same question done as a percentage. The percentage error is the ratio of the error to the correct answer. The correct answer would be for the bank or the exchange company to give us 45.977. That would have been 100%. But they shaved this amount off it. So what percentage did they shave off? Well, if 100% is that, how much is this? Draw it as a table. Do the crisscrossing of it. And we find that 0.977 by 100 is equal to that by x. X is equal to 2.12497. So they took away 2.12% in the error. That was the percentage error and the various other errors there as well.